8, 5, 2, negative 1. What is the first number in that pattern? Lexi.
Like the next number?
What is the first number in that pattern?
Like 8?
Yes.
Okay.
Explain in words what is happening each time. Somebody tell me in their own words what is happening. Riley.
It's consecutively going down.
So the next now formula is the next term equals now plus or minus the common difference, depending on if it's positive or negative.
Is this the recursive?
So our common difference is 3. This is not recursive or explicit. This is just next now, just to get you guys used to what's happening here. So this is similar to recursive, though, if that's what you're trying to compare it to. Yes. Grace. So next equals now plus or minus the common difference. What is our common difference? It shouldn't be, sorry, it should be negative 3.
Okay, that's good.
So it would be now. You take the term you are on now and you. So it would be now minus 3. So the next term equals the term you are on now minus 3, right? The term you are on minus 3. So that's what that's happening there. This is just getting you used to the formulas. We won't really be doing much with this from here. But this is just like to get you used to what's happening with the patterns. What's up? Not right now. Cassie, what's the starting term?
5.
Okay, in your own words, Connor, tell me what is happening.
It's going up by 6.
So the common difference is?
6.
So we write next equals, now, Kaylee, plus or minus what?
6.
You're adding 6. So to get to the next term, you take the term you're on now, 5, and add 6, and that gets you the next term. You take the term you're on now, 11, and add 6, and that gets you the next term, right? So that's what that next now is happening there. So Blaine, what is my starting for the next one there?
11.
And Josh, what is your own words of what's happening there?
It's going down by
Very good. So your common difference is?
negative.
Josh, what is your common difference?
5.
Not just 5, but?
Negative 5.
There you go.
Sorry,
So, Miguel, next equals now? Minus 5. So these are going to get you used to the formulas. We're not going to be really using next now. This is very similar to the recursive formula. And I will show you exactly what I mean by that in the next few slides here. And then we are going to be writing equations for or formulas for the rest of the hour. These formulas, you get a formula sheet on your EOC. It is an unmarked formula sheet, meaning that you get a bunch of formulas, and you have to know what each formula is.
Yay.
So like these formulas that you're learning today are on the EOC sheet. But there's a ton of formulas, and some of them you won't even need to use because they give you the same reference sheet for the Geometry EOC and the Algebra 2 EOC. We don't give those ones here, by the way, so you don't have to take a Geometry or Algebra 2 EOC. But some people in the state do, so they give the same one. Why they don't have different ones for Algebra 1 Geometry and Algebra 2? I don't know. They did when I first started teaching this, so I have no clue why they decided to change it.
To confuse us.
It's more confusing. It seriously is more confusing. It was a much easier formula sheet to use before they changed it.
Dark magic this.
We can't. We have to do what the state provides. We even have to provide certain graph paper. Like, we have to do certain things. All right. Explicit versus recursive. So an explicit rule gives a function, gives a sub n as a function of the term's position, number, and line in the sequence. So a sub n is a position in line. N can be substituted for any position in line. So if I want the first position in line, or if I want the second position in line, I would put 2 if it's the second position. Or if I want the 23rd position in line, I could say A sub 23, and that's the 23rd position in line. What's up?
The thing just fell down.
Okay.
Idiots put that up.
Michael. I know.
It clearly wasn't put up good the first time.
All right. It doesn't matter. That's irrelevant right now. So it allows you to find any element of a sequence without knowing the element before it. This formula is going to look very, very similar to slope-intercept form. Substitute. I missed lots of letters in there. I think U and T were missed there. There they are. All right, but this is going to look very similar to slope-intercept form. The other one is the recursive rule. The recursive rule gives you the beginning term of the sequence, which we call A sub 1. That is the first term. Because it has the 1 in for n. Do you see that 1 in place of the n in the previous one?
Yes.
So that means the first term in line of a sequence and tells you how A sub n is related to one or more of the preceding terms. So it tells you how the next terms are related using the common difference. So kind of like our next now from the previous page. That's what that one will be similar to. So it tells me how a sequence starts and tells me how to use the previous values to generate the next values. In a explicit rule, you can find any term. So if somebody asks you to find the 100th position in line, you can plug 100 in and get that answer. In a recursive rule, you cannot just plug it in. In order to find the 100th term, you have to find the second term. The second term is used to find the third term. The third term is used to find the fourth term. And then you would have to keep doing that until you got to 100. So this form takes on what happened before, whereas the other one is more of an equation you can use in all situations. All right? All right, so let's look at the actual formulas. These formulas will be given to you on your test. Okay, so explicit. This is an example here. A sub n equals 2n minus 1. That looks familiar, doesn't it? That looks kind of like y equals mx plus b. N is your current place in line. So you can substitute any place in line and find its output. So the arithmetic explicit is as follows. A sub n equals a sub 1 plus n times plus 1, plus the quantity n minus 1 times d. So you distribute once numbers are substituted in to get it looking more like slope-intercept form. So first of all, a sub 1 is the first term in the sequence. You know how we said like the start when we were looking at the next now? That's what that is. And D is the, who remembers what D is?
I think Greg's right.
So you know how in y equals mx plus b, we never replace y or x?
That's right.
You guys remember that?
Yeah.
So you will not
Your icon?
replace a sub n or n unless trying to find a certain number term. So the only ones that we will replace are these two. The The ones that are in boxes are the only ones that are replaced. A sub n and n will stay in the problem. As we said before, n is the current position in line, and you can substitute anything in it. So we've already stated that n is the current position in line. All right. Next one there is the recursive. The recursive is more like a next now. So this is the whole entire example for a recursive. You get the first position in line, so this is the first term, and it tells you what you can do to the previous term. So n minus 1 means the previous term, because minus means the one before, right? So you take the previous term and add 2. So what would the second term be? 3. What would the third term be?
7.
5. So you keep adding 2. So the subscript again, n is the place in line. We've talked about that already. What term you are trying to find. N minus 1 is the term before the previous term. So you need the term before. So the arithmetic sequence is a sub 1 equals something. And then you have a sub n equals a sub n minus 1. These two are the things you will be replacing. Those two boxes are what you'll be replacing. A sub 1 is your first term, your starting term. And a sub n minus 1 means use the previous term to find the next. And then D is your common difference again. All right. So go ahead and get that stuff written down and flip to the first few examples, and we're just going to do examples for the rest of the hour.
Good. All right, let's do this.
No.
Riley, stop asking questions. The answer is no holding.
I did not say it like that, so I just said no, but you know. All right, so for each one of our patterns, we're going to write the recursive and the explicit rule. I am going to write the explicit and recursive rules over here off to the side, so we have them at all times to reference. Remember, we only replace the pieces that I have boxed. Okay, so let's start with the explicit rule, but first we're always going to determine our common difference in our first term, because those are the things we're going to need the most. So who can tell me the common difference of this first pattern? What is happening each time? Jordan? It's not minus 12, it's 12. And what is our first term of that sequence? What are we starting with, Alyssa? Okay, so those are the first things you're going to do. Then you are going to write the explicit. We know that the explicit is a sub n equals a sub 1 plus n minus 1 times d. Again, this will be given to you on your test. You just have to replace those pieces. So if you're just replacing those pieces with our first term and our common difference, who thinks they could tell me what that formula would look like before we distribute? What would that look like? Kaylee, you want to try? So only replace the things that have highlights on it. So you're going to start with a sub n, because it's a subscript. That's where the sub comes from. I'll get you notes in a second. Equals?
Negative 30 plus n minus 1 equals times 12. That not equal. Yeah.
All right, guys. Stop talking. So, anybody confused on how those numbers got placed into the formula? Anybody confused on how those numbers got placed into the formula? Okay, from there we distribute the 12. So we get a sub n, because it's a subscript, that's why you say sub. Sub, meaning like a submarine goes below the water. So that's negative 42 plus 12n. The recursive formula is a sub 1 equals, and then a sub n equals a sub n minus 1 plus d. So again, we replace only what's highlighted. So who thinks they can do the recursive one then? Who thinks they want to try the recursive one? Go ahead, Jordan.
Okay, so A1 is negative 30.
So a sub 1 is negative 30, and then?
And then plus D is... Well,
Right, but say the whole entire thing.
Oh, okay, so A sub 1 equals negative 30. What is it like?
A sub n
A sub n equals A n
sub
n minus 1 plus 12.
Good. So that is your recursive, and you don't have to simplify that from there. These are on different levels, so do not add the negative 1 to the 12. So all this is today is like literally just plugging things in. So if you get confused anywhere, let me know. All right? But that's really all we're doing today. Gianna,
I got confused on the recursive part.
what are you confused about?
Like,
It's just, the recursive part just tells you the first term and what you need to do to that term to find the next one. So this just means the previous term. So if we're on the first term, it's negative 30. To find the next term, you have to add 12. So negative 30 plus 12 is negative 18. So this just takes the place of the previous term, like the next now. This is like next equals now plus d. Instead of next and now, we're using a sub n and a sub n minus 1. Does that make a little bit more sense?
Yeah.
Okay.
Why do I have to use forms?
Because it allows you to say like a sub 1 equals a sub 1 minus 1, which is 0. So you need to use a sub 0 plus d to find to find a sub 1. That's why they're using that. It lets you say the position in line that way. A sub 1 and the common difference here. So what is Brian, what is my first term in number 2?
500.
And what is my common difference, Josh?
you go down by 400.
Not 400.
Oh, wait, 300.
There you go. So that's negative 300.
I don't know why.
It's okay. Okay. Justin, give me the explicit formula before we distribute. So first give it to me before we distribute.
distribute
A sub n equals,
500 minus 300 n minus 1.
you put it in front, okay. So n minus 1 times what?
300. Negative 300. She just showed us to write it differently.
The reason we don't write it that way in this class is because on the EOC, it does not have it written that way on the formula sheet. So we mimic the formula sheet so that when you see it on the formula sheet, you know how to, like, you know what I mean? You don't get as confused. I understand why you would put it in front because it makes more sense that way, but for whatever reason, that's what it does on the formula sheet, and we'd rather you see it exactly how it is on the formula sheet. Does that make sense? Okay, so we distribute. And I get a sub n equals 800 minus 300n. Okay, Gianna, try to get this formula for me because this was the one that you said you were a little bit confused on, so I want to see that you're understanding what I'm saying.
A sub n equals a n minus 1 plus, no, minus 300.
You forgot something. What's the first term? You have to tell the people the first term so they know where to go from there.
500?
Yeah, so that has to be in there. Because if you just have minus 300, they don't know where to start subtracting 300 from. So we know to start at 500 and continue to subtract 300 to get our terms. Does that make sense?
Yeah.
All right, questions so far before we do the next one? Is it really that confusing? Okay. Again, just think of it like this. I'm in the first position in line. First position in line, my starting number is 500. If you're the line leader, you are the first person, right?
Right.
In order to figure out who is the next person in line, so like if I wanted to know the third person in line, and granted these aren't numbers, so this is going to be as easy this way, but if I want to know who the third person in line, I have to look at the second person in line, and they can, then go backwards to them and add that number. So if each of you had numbers in this classroom, so if I started with Emma as position 1, 2, 3, 4, 5, and 6, so just across the front here, do you see that? If Emma is position 1, she's 500. If Kaylee is position 2, she's 200, right? In order to find Justin's answer, right, Justin's number, he's position 3. So to find position 3, I have to go to the previous position, which is position 2, right? And Kaylee is 200, and she has to take away 300 from 200 to tell him that it is now negative 100. Does that make a little bit more sense? I know that's not 100% sense. This is new to you, but at least that gives you a little bit more of a visual of what's happening there. All right, so what is the pattern here? First of all, this is term 1, term 2, and term 3. How many squares are in term 3? Term 1?
3.
How many are in term 2?
5. 6. Wait,
5.
5. My bad. And 7.
Okay, so a sub 1 is what, Blaine? What is the first amount of squares?
4.
The common difference is what, RC?
2.
No. Tanari, give me the explicit formula before distribution.
A subject n equals 3 plus parentheses n minus 1 from 2.
So then we can distribute. And we get a sub n equals 1 plus 2n. Do you understand how we got here?
Oh, yeah.
You do understand that? Are you sure?
Yeah, I thought.
And then I distribute it. And then 3 minus 2 is 1.
I thought the number wasn't the number that you made the number. I thought on the second line, the 1 in the parentheses, I thought that was a min. But it wasn't. I'm losing brains.
Colin, give me the recursive formula.
Alright. Let's see. Alright. Okay. Bingo. Alright. Of course you picked the hardest one for me. It's a sub n equals the a and I forgot the sub or whatever.
You're fine.
Okay. Minus 1 and then plus b.
Which is?
Which is, it would be plus 2.
Okay, you forgot the first term. You have to tell them the first term in order to find the next term. What's the first term?
3.
You guys need to tell them the first term, or else the person will have no clue where to go from there. Can we stop with that question? It has nothing to do with directly using things in class. It has everything to do with learning critical thinking skills. That's what these are about. Okay, we are going to look at the word problems next. We're going to skip example 4, so go to the next example.
Wait, we didn't do number 4.
Yeah, she just said we're skipping it.
Forgive me, Father.
All right. The first term of the sequence is 5. Each term of the sequence is 15 more than the preceding term. So, what is my first term, Jayla? And what is my common difference, Grace? Nope, be careful. Read the problem again. 15 more, so that is your common difference. So you're adding 15 each time. So, Miguel, you are going to write the explicit formula for me. What is the explicit formula for this one here? Good.
Plus n minus 1, and then 15.
Good. So then we distribute. So a sub n equals negative 10 plus 15n. Okay, Emma. Give me the recursive formula. The bottom one.
Let me look at my notes.
You're fine. A sub 1 equals 5, okay. What does a sub n equal?
15.
You still have to, you have another thing. You have to say this here.
A sub n minus 1 plus.
Good job. So you replace those pieces there. Not that piece. That was a lie. Okay. So questions there before we do one more example on the next page. So those ones are a little bit easier, I feel like, because you don't even have to think. Like it says, this is my first term. This is what I'm doing each time. So those are a little bit easier. You don't have to actually look at a pattern. All right. We are going to do example 7, and then I will have you guys, well, I'll try to do both of these with you guys, and then I'm going to have you guys do the homework. So write the first 6 terms of the sequence. So, first of all, is this number 7 recursive or explicit?
Oh, explicit. No, it's recursive.
It gives you the first term, so that means it is? Anytime it gives you the first term, it is recursive. So this is recursive. So my first term is, what is my first term? It already tells you.
Negative 6.
And what do we have to do each time to get the next term?
Add 4.
So the next term would be, then,
2.
then,
6.
then,
10.
and one more?
14.
So that's the first 6. So this is position 1, position 2, position 3, position 4, position 5, and position 6. So just graph whatever fits on the graph. So that's 1 comma negative 6, 2 negative 2, 3 2, 4 6, and 5 10. I'm not going to worry about the other one. Remember, we are doing arithmetic sequences, so we do not connect the points. Okay, this is different than this one here, which is explicit, right? In order to do an explicit, you have to actually do an input-output list. So when n equals 1, 2, 3, 4, 5, and 6, what is your output? So when it's explicit, you have to do an input-output list. And you'll do the first 6 terms, so that's why we're doing this. So when n is 1, we do 8 times 1 minus 8, and that is?
0. Yeah.
And some of you will figure out the pattern and not have to do all of them. 8 sub 2 is 8 times 2 minus 8. That's our input. So 16 minus 8 is? What are we doing each time?
Add 8.
So yes, we are adding 8. So just continue to add 8 to finish your pattern. And only 2 of them fit on your graph.
Yay.